Hello, today our class is on methods of correlation. First, we will see introduction. In the previous class, we have explained the meaning and types of correlation. And in this today, we will discuss methods of studying correlation. Um, okay, there are five methods we use to study the correlation. That is, first one is scatter diagram, second is graphic method, third one is Correl-Pearson's coefficient of correlation, fourth is Spearman's rank coefficient of correlation, and fifth is coefficient of concurrent deviations. Because of first time, we will consider three methods in this class and two methods in the next class. Okay, while the first two are basically graphic methods, the other are mathematical methods. First two, scatter diagram method and graphic method, are graphic methods, whereas Correl-Pearson's coefficient of correlation and Spearman's rank coefficient of correlation, coefficient of concurrent deviations, are nothing but mathematical methods. Okay, both the scatter diagram method and graphic method would reveal the nature of correlation, that is, whether it is positive or negative. In other words, they provide just the direction of variables, the direction of variables in which they are moving. They do not give the extent of correlation between the variables. Okay, what extent, what degree of correlation exists between the variables do not revealed by these methods, right? To overcome this drawback, mathematical methods have came into existence, and they express both the nature and extent of correlation between the variables. Okay, Correl-Pearson's coefficient of correlation is one such measure available to us, right? For today's class, we will first discuss scatter diagram method. Um, in scatter diagram method, a scatter diagram is also called as datogram, okay, or scattergram. We can also call it as scattergram or datogram. According to this method, the values of each pair of observations are shown on graph paper with the help of a single dot. Okay, thus we get as many dots as number of pairs of observations. If the number of pairs of observations increases, the number of dots will also be increased. While plotting on the graph paper, we will come to conclude, okay, whether the relationship, that means correlation, exists between the variables or not. With the help of the dots plotted on the graph, we get a visual idea of the relationship between the two variables. Okay, by seeing the graph, we can say the correlation whether it exists or not. While the closeness of the dots on the diagram indicates the high degree of correlation. When the dots are close to each other, that reveals us the high degree of correlation, and the correlation is said to be positive if the points on the diagram rise from the lower left hand corner to the upper right hand corner. Okay, lower left corner to the higher left corner, if the dots are uh, rising. Okay, correlation is said to be positive if the points and the higher rise from the lower left hand corner to the upper right hand corner. On the other hand, correlation is said to be negative. The points show a decreased tendency from the upright, okay, upper right hand corner to the lower right hand corner. How these two will appear? One is the positive, perfect positive correlation diagrams looks like a supply curve, whereas the perfect negative correlation diagrams is look like a negative, that is a demand curve. Okay, negative, perfect negative correlation curve looks like a demand curve, whereas positive um, positive correlation diagram looks like a supply curve, right? On the other hand, correlation is said to be negative. The points show a decreasing tendency from the upper right hand corner to the lower left hand corner. If all the points fall on a straight line, rising from the left hand lower corner to the right hand upper corner, correlation is said to be perfectly if it is linear and they are moving in, as we see the same in the graph paper. Okay, you will see the same on the graph given in the PPT, right? uh, Right. This is on the other hand, if all the points fall on the straight line, decreasing from right hand upper corner to the left hand lower corner, correlation is said to be perfectly negative. That is, r is equal to -1. Correlation is said to be absent if the plotted dots line on a straight line parallel to the x-axis are in a haphazard manner. That is, r is equal to 0. The and diagrams will show us the okay, that is zero relationship, which will be explained if you look at the PPT. You will come to know. Okay, high degree of positive correlation. First diagram shows that a high degree of positive correlation, and high degree of negative correlation shown by the second graph. Whereas in first graph, the high degree of positive correlation means the from left to right the dots are rising. Okay, uh, from lower left corner to upper right corner the dots are moving, hence it is a high degree of positive. Whereas in case of lower left upper left corner to lower right corner, when the dots are moving, the correlation, okay, negative, high degree of negative correlation can be estimated, right? Next, lower degree of positive correlation. When the dots are not in the linear form, of course, they are moving one another away from one another. There can be lower degree of positive correlation can be shown. Whereas the same manner from left to right, the dots are falling in nature and they are not closer to each other. They are the density is very low. Means the dots are scattered over there, which shows the lower degree of negative correlation. Where if the dots are scattered all over the okay quadrant and they don't have any relation, then r is equal to 0. We see that no correlation exists between the given variables. These are shown in the PPT. Right. Next, uh, merits of scatter diagram method. Okay, what are the merits that we have in the scatter diagram method? We'll discuss here. It is a simple and visual method, okay, which does not require any complicated mathematical calculations. No, okay, you need not be the expert in mathematics to okay solve the or to know the relationship between the variables by using this scatter diagram method, right? And it tells us at a glance whether there is any relationship between the variables or not. Okay, within a glance of time, we can come to know whether the relationship exists between the variables given by seeing the graph itself. In a second, you can tell us. Okay, and third, it indicates the direction and extent of correlation between the variables. It indicates direction and extent, whether they are the variables are moving in same direction or opposite direction. Okay, we will know, come to know. And at what extent, when they are far away from each other, there is a low degree of okay correlation. If they are scattered over here and there on the quadrant, there is no correlation. If they are closer to each other, there may be high degree of correlation can be revealed. And fourth, it tells us whether the correlation is linear or non-linear. We can say whether they are moving in the same direction near to each other, near linear form or not. We can come to know whether linear or it also helps to estimate values of dependent variables on the basis of values of independent variables, right? Next, it helps in obtaining the line of best fit. It helps in obtaining the line of best fit, and it helps to locate the abnormal points in the data. If any point or points fall far away from other points of the data, it indicates the abnormal tendency in the value of variables. Such an abnormal tendency necessitates further investigation and detailed analysis. Okay. Unlike the mathematical methods, it is not influenced by the extreme values of the data. Right. Uh, However, this method has certain limitations. We will discuss what are the limitations that this method suffers with. It gives only a rough idea of the relationship between two variables. Okay, it won't be precise in nature. That means it won't be precise in nature. It will give a rough idea of the relationship between the variables, and definite conclusions cannot be drawn on the basis of scatter diagram. Okay, definite conclusion cannot be drawn because it's a rough idea. We can't make definite conclusions based on this scatter diagram, and it does not measure the degree of correlation in math numerical terms. It does not measure the okay, okay, can you reveal degree of correlation in math? No, there is no ability. Numerical terms we cannot express the degree of correlation. And further, it is useful to study the correlation between only two variables. It is not possible to study the correlation between more than two variables. It is only restricted to study the correlation uh, between the two variables only, right? And now we'll discuss graphic method. According to this method, the value of variables are plotted on a graph paper, and separate curves are obtained for each variable. Okay, by examining the closeness and direction of curves, we can determine the direction and extent of relationship between two or more variables. Correlation between two variables is said to be positive. Both curves are moving in the same direction, either upward or downward, but they need to move in the same direction. Okay, whereas in case of um, if the curves move in the opposite direction, the correlation is said to be negative. In positive correlation, the okay variables move in the same direction. Okay, whether either it can be upward or downward direction, but they move in the same direction. Whereas in case of negative correlation, okay, the curves moves in the opposite direction, and erratic fluctuations in the curves indicate either the absence of correlation or a low degree of correlation between the variation variables. That means erratic fluctuations in the curves indicate either the absence of correlation or low degree of correlation between the variables. Like a scatter diagram, graphic method is also simple and visual method which does not require any mathematical calculations. Okay, there is a phobia. Some people will feel that, oh, mathematics, it is not our work. We are not skilled in that field. But that is not required for to study the correlation by using graphic or scatter diagram method. Both are easy to calculate. They don't require any mathematical calculations. The greatest advantage of this method is that it can be used for determining the relationship between two or more variables, whereas in scatter diagram only we can study the correlation between two variables, whereas in case of graphic method we can study more than two variables also, right? Though this method helps to get a rough idea about the relationship among the variables, it does not measure the degree of correlation in exact numerical terms. Of course, there is an advantage over the scatter diagram, okay, in measuring the more number of variables, correlation between the more number. It suffers with, it gives only rough idea relationship among the variable, and it does not measure the degree of correlation in exact numerical terms. We are not in a position to tell the degree of correlation in exact numerical terms. Okay, this is 5 units, so we can't in the we are not in a position to express the same the parameters such as units. Okay, thus with the help of this method we cannot draw definite conclusions about the relationship among the variables, uh, which will be understood by seeing at the PPT. by considering one um, numerical example on this, right? Calculation of correlation by graphic method. It was given the follow data determine the correlation by using graphic method. Here are given 1978, 79, 80, 81, 82, 83, 84, and average income, average expenditure of the parents is given. That is, average income in 1978 is 100, is whereas 79 150, 80 200, 81 250, 82 275, 83 300, and 84 350. Average expenditure is also given in the year 87, 75, 78, 1978, 75, 79 it was 100, and the 80 was 125, 81 125, 82 150, and in the 83 175, 84 225. uh, this is the data given. Based on this, we need to draw a graph. Okay, years are shown on x-axis, and figures relating to average income and expenditure are shown on y-axis. Okay, if you see x-axis years, and on y-axis income of expenditure. Okay, income and expenditure. If you draw the graph lines, when you see, look at the PPT, you will come to know that is a, that is b, a curve is in a color, b is in red, expenditure. Income curve is above, and below curve is expenditure curve. Scale is taken as on x-axis 1 centimeter is equal to 1 year, on the y-axis 1 centimeter is equal to 50. The graph shows that the variable income and expenditure are closely related. Okay, they are near to each other. As your income increases, your expenditure also increasing, right? The same manner, they are close to each other. Now two separate curves, based on the data we have drawn the curves, and they are close to each other, and that reveals, okay, they are closely related. Okay, the between the correlation exists between the average income and expenditure. They are, it says that they are closely related. And now we'll discuss Carl Pearson's coefficient of correlation. um, this is a mathematical method that we, okay, have here. Carl Pearson's coefficient of correlation, which is also called as Pearsonian. Okay, Pearsonian coefficient of correlation is a popular mathematical method of measuring correlation between the variables. Pearsonian coefficient of correlation is denoted by letter R, small r, and is computed either by direct method or by shortcut method. First we will see the direct method. According to this method, coefficient of correlation is a ratio of the covariance to the standard deviation in the two series, right? It can be explained symbolically by R is equal to, when you see at the PPT, you will have sigma xy. Sigma is your summation, not standard deviation. Summation, that means sum of the x into y, x series and y series values by n number of items. Okay, that is some of the frequencies. Also we can call them as sigma x. Sigma here, small sigma, that shows the standard deviation of x series into standard deviation of y series. X deviations of x series taken from its arithmetic mean, that is x minus x bar is small x. Okay, and y, small y, deviations of y series taken from its arithmetic mean, that is y minus y bar, that is small y, and sigma xy, some of the products of deviations of x and y series taken from their respective arithmetic mean. And sigma x is standard deviation of x series, and sigma y is standard deviation of y series. And number of pairs of observations, that is n, where some of the frequencies we are told, but here we are taking two pairs of observations. Okay, two series we are considering. Hence, as we have considering two or more series, the number of pairs of observations which are pertaining to the given series are called as n. Okay, can be represented with the n. And now we'll consider one example for better understanding. That is, calculate the coefficient of correlation between x and y series okay, with the given data. He has given that number of pairs observed, that is x series 100 pairs, 100, y series is 100, and hence the pairs 100 pairs x y pairing, and okay, it is standard deviation is for x series 9, and whereas standard deviation of y series is 4. Some of the products of deviations of x and y series from their respective arithmetic means is that is 1340. He has given. Based on this data, okay, considering this data, we need to calculate the coefficient of correlation between x and y. That is, we know the formula that is given by Carl Pearson. Okay, Parsonian coefficient of correlation, that is small r is equal to summation big sigma, we call it as big sigma, okay, x into y by n into sigma x into sigma y. Given that n is equal to 100, sigma x is equal to 9, and sigma y is equal to 4, sigma xy is equal to 1340. Substituting the value in the formula, r is equal to 1340 by 100 into 9 into 4, that we know the values as per given information. We know that n is equal to 100, standard deviation of x series is 9, and standard deviation of y series is 4. The product of x and y series is 1340. If you substitute all this in the given formula, we'll have 1340 by 900 into 9 into 4, that is 1340 by 3600, which is equal to 0.37. The coefficient of correlation between x and y is 0.37. 0.37. We'll have another example. He was asked to, if the covariancy between x and y series is 16.2, and the variancy of x and y are respectively 25.2 and 15.5, find the coefficient of correlation between x and y as asked. And now we need to solve the problem. Covariancy between two variables is the sum of the uh, product of some of the products of the deviations of two series taken from their respective arithmetic mean, divided by the number of pairs observed. Thus, covariance between x and y will be sigma xy by n, that is 16.2 is given. Calculation of standard deviation of x series, that is small sigma x, okay, which is equal to sigma x square variance of x series. Okay, we are given that sigma y x square, that is 25.2, that is nothing but variance of x series. With this we can, okay, sigma variance is given, that is sigma x square, okay, is given 25.2. With that we can calculate sigma x standard deviation, that is sigma x square is equal to 25.2. Sigma x is equal to under root 25.2, that is sigma x is equal to 5.02. Okay, calculation of standard deviation of y series, sigma y is equal to sigma y square variance of y series. Okay, we are given that sigma y square is equal to 15.5, and this is what we call it as variance of y series. And now we need sigma y, that means standard deviation of y series, that is 15.5 under root, which is equal to sigma y is equal to 3.94. Now calculation of coefficient of correlation with the information that we got from the given data, that is r is equal to sigma x y by n into sigma x into sigma y. If we substitute these values, we know that sigma xy by n is nothing but 16.2, and sigma x is equal to 5.02, and sigma y is equal to 3.94. Substituting these values, you will have r is equal to 16.2 into 5.02 into 3.96. Okay, that is 16.2 by 19.78, which is equal to r is equal to 0.82, and this is nothing but coefficient of correlation between x and y, which is equal to 0.82. Okay, and now procedure to calculate the Pearson's coefficient of correlation, right? I will see the procedure. We'll go through the procedure and we'll solve one problem. Calculate the arithmetic mean of x series, that is x bar. Calculate the arithmetic mean of y series, that is y bar. And third is take the deviations of x series from its arithmetic mean, and that is x bar, and denote these deviations by x, okay, small x. Square the deviations of x series and find the total of sigma x square. Take the deviations of y series from its arithmetic mean, that is y bar, and denote these deviations by y. Square the deviations of y series and find out the total, that is sigma y square. And now multiply the deviations of x and y series and find the total sigma xy. Okay, that means the deviations of x series and y series are multiplied, and their sum is called as sigma product of sigma xy. It's nothing but then we need to find out the last step by using substitute the values of sigma xy, sigma x square, and sigma y square in the formula and obtain the coefficient of correlation. This is the procedure given to calculate the Pearson coefficient of correlation for a given series. For example, we will consider one example for the better understanding of this. He has given price in rupees and demand in kgs. Okay, and that were shown on the PPT in red color, and we need to solve based on this data. Okay, first you take x 4, 5, 6, 7, 8, 9, 10, 12, 14, 15, and now x minus x bar. X bar is nothing but the arithmetic mean of the x series, that is sigma x by 90. Okay, sigma x is equal to 90, and number of observations are 10. Sigma x by n is nothing but 9. The 4 minus 9 minus 5, 5 minus 9 minus 4, that is x minus x bar is equal to small x, which we require to calculate the Karl Pearson's coefficient of correlation. And that 6 minus 9 is equal to minus 3, 7 minus 9 is equal to minus 2, 8 minus 9 is equal to minus 1, 9 minus 9 is equal to 0, 10 minus 9 is equal to 1, 12 minus 9 is equal to 3, 14 minus 9 is equal to 5, 15 minus 9 is equal to 6. These are the new deviations that we got from the given formula, given data. And now we need to multiply x square. Okay, that means you need to square the what we got from the arithmetic mean, deviations what we got from the arithmetic mean, that is x square will remove the algebraic signs, that is minus 5 whole square is nothing but plus 25, minus 4 whole square is equal to 16, minus 3 whole square is equal to 9, minus 2 whole square is equal to 4, minus 1 whole square is equal to 1, 0 whole square is equal to 0, 1 whole square is equal to 1, 3 whole square is equal to 9, 5 whole square is equal to 25, 6 whole square is equal to 36. We need to submit the deviations, that is sigma x square is equal to 126 we will get. He has also given the demand for the demand for the given commodity along with price, and now we need to consider the demand of when the price is 4, demand is 20, where we will require in order to establish the relationship between these, we need to calculate y from the arithmetic mean, that is y bar, y minus y bar. Here the number of sum of the observations are 130. Okay, that is 130, and number of observations are 10. We'll get 13 will be the y bar, that is arithmetic mean of y series, and y minus y bar, that is 20 minus 13 7, 18 minus 13 5, 18 minus 13 5, 15 minus 13 2, 12 minus 13 minus 1, 12 minus 13 minus 1, 12 minus 13 minus 1, 10 minus 13 minus 3, 8 minus 13 minus 5, 5 minus 13 minus 8, and we need to make y square. Okay, square the y series which we got in order to remove the algebraic signs, that is 7 square is equal to 49, 5 square is equal to 25, 5 square is equal to 25, 2 square is equal to 4, 1 square is equal to 1, 1 square is equal to 1, 1 square is equal to minus 1 square is equal to 1, minus 3 square is equal to minus 3 square is equal to 9, minus 5 square is equal to 25, minus 8 square is equal to 64. If you summate all these, that is sigma y square is equal to 0, 4, and x into y, thus which we got from the subtracting, we get the series, that is from their corresponding arithmetic mean that can be multiplied, x series and y series. Minus 5 minus 7 minus 20, 35. Okay, and minus 4 minus 5 minus 20, minus 3 minus 5 minus 15, minus 2 minus 4, that is minus 2 plus 2 minus 4, and minus 1 minus 1 minus 1 minus 1 plus 1 0, minus 1 0, 1 minus 1, that is minus 1, 3 minus 3 minus 9, 5 minus 5 minus 25, 6 minus 8, that is minus 48. If you summate all these, you will get sigma xy is equal to minus 156. Okay, we got all these, and we need to substitute the same in the formula, that is sigma xy by under root sigma x square into sigma y square. Here sigma xy that we got is minus 156, and sigma x square is equal to 126, and sigma y square is equal to 204. Substituting the values of r is equal to 156 by under root 126 into 204, which gives rise minus 156 by under root 25,704, which gives rise minus 156 by 160 under 25,704 under root value is 160.33. 1 minus 156 by 160.33 is equal to 0.97. Thus there is a high degree of negative correlation between the price demand for the commodity, okay, which we will conclude from the solution, right? Next we will have shortcut method to calculate the Pearson's coefficient of correlation. We'll see when actual means are in fractions, the computation of correlation by direct method involves tedious calculations and would take a lot of time. In such cases, deviations taken from assumed mean would minimize the calculations and thus save time. Okay, this method of finding out correlation is called shortcut method, is computed with the help of certain steps. We will discuss here the procedure. First is take the deviations of x series from an assumed mean and denote these deviations by dx and find the total of sigma dx. Okay, take the deviations of y series from an assumed mean and denote these deviations by dy and find the total of that is dy, sigma dy we call it as, right? And third one is square dx and find the sum of the total of sigma dx square, and fourth is square the dy and find the total of sigma dy square, multiply dx and dy and find the total, that is sigma dx into dy, and sixth one is substitute the values of sigma dx dy, that is sigma dx square and sigma dy square in the formula, and you will get r is equal to n to sigma dx into dy minus sigma dx into sigma dy by n under root n into sigma dx square minus sigma dx square, okay, minus sigma dy whole square. Okay, this can be reframed as sigma dx into dy minus sigma dx into sigma dy by n by under root sigma dx square minus sigma dx whole square by n sigma into under root sigma dy square minus sigma dy whole square by n. This is the formula where we need to substitute, where sigma dx into dy, sum of the products of the deviations of x and y series taken from their assumed mean, and sigma dx square is equal to sum of the squares of deviations of x series from its assumed mean. Sigma dy square is equal to sum of the squares of deviations of y series from its assumed mean. Sigma dx and sigma dy refers to the sum of the deviations of x and y series from their respective assumed means. Okay, now we'll consider one problem on this for better understanding. That is x is given that x values are 25, 30, for 52, 40, 20, and 22, 32, 35, 38 and 42, and y is given that 12, 22, 15, 20, 18, 18, 25, 23, 30, 30. Now we need to calculate Carl Pearson's coefficient of correlation for this given data, where X series for we have assumed mean taken it as 35, X minus assumed mean, whereas in case of from actual mean we calculate, we take small x, whereas if we use assumed mean to calculate the deviations, we use dx, that is from x series values x minus a, which is equal to dx. Here the assumed mean is taken as 35, 25 minus 35 minus 10, 30 minus 35 is equal to minus 5, 52 minus 35 is equal to 17, 40 minus 35 is equal to 5, 20 minus 35 is equal to minus 15, 22 minus 35 is equal to minus 13, 32 minus 35 is equal to minus 3, 35 minus 35 is equal to 0, 38 minus 35 is equal to 3, 42 minus 35 is equal to 7. If you we got all the dx values, and now we need to square these dx values. The minus 10 whole square is equal to 100, minus 5 whole square is equal to 25, 17 whole square is equal to 89, 5 whole square is equal to 25, minus 15 whole square is equal to 25, minus 13 whole square is equal to 169, minus 3 whole square is equal to 9, 3 whole square is equal to 9, 7 whole square is equal to 49. This is regarding X series, and now we need to calculate the same for Y series. Y series is given 12, 22, 15, 20, 18, 18, 25, 23, 30, 30. And now we consider, okay, we will take assumed mean for this Y series is 25, that is y minus 25 is equal to dy. 12 minus 25 is equal to minus 13, 22 minus 25 is equal to minus 3, 15 minus 25 is equal to minus 10, 20 minus 25 is equal to minus 5, 18 minus 25 is equal to 7, 18 minus 25 is equal to minus 7, 25 minus 25 is equal to 0, 23 minus 25 is equal to minus 2, 30 minus 25 is equal to 5, 30 minus 25 is equal to 5. These are the dy values that we got from the calculation. Now we need to make it dy square. 13 minus 13 whole square is equal to 169, minus 3 whole square is equal to 9, minus 10 whole square is equal to 100, minus 5 whole square is equal to 25, minus 7 whole square is equal to 49, minus 7 whole square is equal to 49, minus 2 whole square is equal to 4, minus 5 whole square is equal to 25, minus 5 whole square is equal to 25. Dx into dy, that is minus 10 into minus 13, 130, plus 130, minus 5 into minus 3 plus 150, 17 into minus 10 minus 170, 5 into minus 5 minus 25, minus 15 into 18 or not 5, that is dx into dy. Okay, minus 15 into minus the 7, that is plus 91, minus plus 105, minus 13 into minus 7, that is 91, minus 3 into 0 0, 0 into minus 2 0, 3 into 5 15, 7 into 5 35. If you summate all these, that is sigma dx is equal to minus 14, sigma dx square is equal to 900, sigma dy square dy is equal to minus 37, whereas sigma dy square is equal to 455, sigma dx into dy is equal to 196. If you substitute all these in the given formula, that is r is equal to sigma dx into dy minus sigma dx into sigma dy by n, under root sigma dx square minus sigma dx square whole square by n, under root sigma dy square minus sigma dy whole square by n. Okay, here sigma dx into dy that we got is 196, sigma dx is equal to minus 14, sigma dy is equal to minus 37, sigma dx square is equal to 900, sigma dy square is equal to 455, and n is equal to 10, which are required to substitute in the formula. R is equal to, if you substitute the same in the formula, R is equal to 196 minus bracket of minus 14 into minus 37 by 10 by under root 900 minus 14 whole square by 10 into 455 minus 37 whole square by 10. If you simplify this, 196 minus 4 minus 14 into minus 37, you get 518 by 10, by under root 900 minus 14 whole square is equal to 196 by 10 into 455 minus 37 whole square is equal to 1369 by 10. Now 196 minus 518 by 10 is nothing but 51.8, that is 196 minus 51.8, and under root 900 minus 19.6 into 455 minus 13 139 136.9. If you summarize further, you'll get 196 minus 51 is nothing but 144.2, under root 880.4 into 318.1, which is called 144.2 by under root 2 lakh 80,055.24, which is equal to 144.2 by 529.2, which is equal to r is equal to 0.27 that we get. And now we'll do one more problem for better understanding by using a direct original values. Okay, we have steps for this. According to this method, we need not take the deviations of both the series either from the actual mean or from their respective assumed means. Okay, the formula applied here is r is equal to n into sigma xy minus sigma x into sigma y by under root n into sigma x square minus sigma x whole square into n into sigma y square minus sigma y whole square. Okay, where sigma x is equal to total of x series, sigma y is equal to total of y series, sigma x square is equal to sum of the squares of original values of x series, sigma y square is equal to sum of the squares of original values of y series, whereas sigma xy sum of the products of values of x and y series, and is equal to number of pairs of observations. We'll consider one problem here. It has given that x is equal to 10 9 8 7 6 5 4 3 2 1, and y is equal to 25 23 20 16 12 12 10 8 5 4, and this is given. This is shown in red color in the PPT, and we need to calculate x square y square xy, where x square is equal to, first we will say take x square, x 10 whole square is 100, 9 whole square is equal to 81, 8 whole square is equal to 64, 7 whole square is equal to 49, 6 whole square is equal to 36, 5 whole square is equal to 25, 4 whole square is equal to 16, 3 whole square is equal to 9, 2 whole square is equal to 4, and 1 whole square is nothing but 1. If you summate the sigma x is nothing but 55, sigma x square is equal to 385, and now for y series, we add all the values of y series, we will get sigma y is equal to 135, and we will square the values of y, that is 25 whole square is equal to 625, 23 whole square is equal to 529, 20 whole square is equal to 400, 16 whole square is equal to 256, 12 whole square is equal to 144, and 12 whole square is equal to 144, 10 whole square is equal to 100, 8 whole square is equal to 64, 5 whole square is equal to 25, and 4 whole square is equal to 16. If you add these, that will become sigma y square, which is equal to 23 03 2303, and now we need to find out the product of x and y series values. That is product of x is 10 into 25, that is 250, 9 into 20, that is 207, 8 into 20, that is 160, 7 into 16, that is 112, 6 into 12, that is 72, and 5 into 12, that is 60, 4 into 10 40, 3 into 8 24, 2 into 5 10, and 1 into 1 into 4, that is 4. We got all the values, and now we need to substitute the same in the given formula, that is r is equal to n into sigma xy minus sigma x into sigma y, okay, by n in under root n into sigma x square minus sigma x whole square into under root n into sigma y square minus sigma y whole square. Okay, if you substitute this in this formula, that we know that n is equal to 10, sigma xy is equal to 939, sigma x is equal to 55, sigma y is equal to 135, and sigma x square is equal to 385, and sigma y square is equal to 2303. Okay, that is r is equal to, substituting the same in the r is equal to, that is 10 into 939 minus 55 into 135 by under root 10 into 385 minus 55 whole square into under root 10 into 1303 minus 135 whole square, which is equal to 10 into 939, nothing but 9390, minus 55 into 135 is equal to 7425, by under root 10 into 385 is nothing but 3850, minus 55 whole square is nothing but 3025, that is 3025, into under root that is 10 into 2303 is equal to 23,030, minus 135 whole square is equal to 18,225, which is equal to 1965, that is 9,390 minus 7,425 is equal to 1965, by under root 3,850 minus 3,025 is equal to 825, into uh, 23,030 minus 18,225 is equal to 4,805. If you multiply these, okay, 1965 by 825 into 4,805, if you multiply, this is 1965 by under root 39 3 lakhs 96,000, no, 39 lakhs 64,125, 196, okay, 1965 by, if under root 39 lakh 64,125 is equal to 1991.011, hence 1965 by 1991.099 is nothing but r is equal to 0.987, 0.987. There is a high degree of positive correlation between x and y series will be revealed. That is assumptions of Pearsonian coefficient of correlation we will discuss now. That is Karl Pearson coefficient of correlation is based on a few assumptions. There is a linear relationship between the variables studied, okay, and the variables under study are affected by a large number of independent causes, right? And the third assumption is there is a cause and effect relationship between the variables under study. Okay, these are the assumptions that were given by Pearsonian coefficient of correlation, and merits and limitations of Pearsonian coefficient of correlation are it assumes. First we will discuss merits. Karl Pearson, okay. Karl Pearson's coefficient of is a mathematical method to find out the nature of extent of relationship in exact numerical terms, and the coefficient obtained is a pure number which is not affected by different units of measure in which the value of the variables are expressed. This is one merit. Thus Karl Pearson method measures the relationship in a single figure, which also reveals the direction and degree of correlation. However, it suffers from a few limitations. That is, it assumes that the data contain linear relationship, but linearity is a rare phenomenon in our particular practical life. The second is the interpretation of correlation coefficient needs greater amount of care and experience. And third is the value of the correlation coefficient is subject to the influence of extreme values of the items of data. And fourth is it involves tedious mathematical calculations, as we have discussed earlier regarding scatter diagram and graphic diagram. Mathematical people who are not having command over the mathematics can understand and do the correlation problems with the help of scatter diagram and graphical method, but it is not an easy task to them for using the Karl Pearson coefficient of skewness. Yes, with this we conclude the topic. Right. Thank you.